Hello class, this is Mr. Hart. In this podcast, we want to continue our discussion of circle geometry, and we want to look at some different types of angles that we can find with a circle. Okay, so in previous math classes, you probably have seen where you take an angle like this, okay, from the center of the circle, and you can find certain things, like we just found the area in the previous podcast, we found the arc length, okay? But what if you don't have an angle that comes from the center? What if the angle actually comes from, say, the edge of the circle, like this? Now we have a very unique situation that you probably haven't dealt with before, because this angle is very small compared to how much of the circle it's covering. Okay, so we could have an angle maybe come from the outside, or maybe it could just be somewhere random in the circle like this. Okay, we've never dealt with angles like this before, where you have to look at where it's coming from, if it's from the center or not. Okay, but we want to learn how to deal with these angles because you will see them. Okay, and we need to be able to find these arcs still, find out how much of the circle they're covering, that type of thing. Okay, so we need to be able to classify these different types of angles we'll see so that we can work with them. Okay, so here's the different categories that we'll see with these angles. So these are the four categories that you will see with angles. Okay, there's what we call central angles, which is what you are used to, where the angle comes from the center. There's inscribed angles, where the angle comes from the edge of a circle. There's what we call circumscribed angles, where the angle is actually on the outside of the circle. And there's interior angles, where the angle is just somewhere random inside that circle. So let's look at each one of these individually, because we're going to have to treat the math a little bit different in each case. Okay, so let's start off with a central angle. So if you have a central angle and you're trying to find a portion of an arc, okay, we're going to usually find the portion of an arc, or how much of the circumference we've got. Okay, then in this case the arc is the same as the angle. So for example, this angle right here is 73 degrees. That means out of the total 360 degrees, it represents 73 degrees of the circle. Okay, likewise, this arc right here compared to the circumference, it represents 73 degrees compared to 360 degrees for the total circumference. Okay, so with a central angle, it's really easy. We don't have to make a distinction. This arc is the same as the angle. Okay, but let's compare that to the next category, which is an inscribed angle. Okay, in this case, the arc is twice the angle. So down here we have a very small angle. This angle is 30 degrees right here. Okay, and it's going all the way out to the other side of the circle. So this angle is only 30 degrees, okay, but the arc that it represents on the edge of the circle is 60 degrees because it had a lot more distance it could work with compared to a central angle, okay? Because you can imagine a 60-degree central angle coming from point A would have to be much larger to cover this much of the circle. But because it's on the edge, it only needs 30 degrees to cover 60 degrees worth of the circle. Okay, so the arc is always twice the angle. Okay, let's just do a quick example problem with this. All right, so let's say we have a circle and it has a inscribed angle that goes to this arc out here. Okay, and this arc is equal to, let's say, 94 degrees. Okay, well, if that arc is being represented by an inscribed angle, then we know that this angle, or this arc, is twice as much as that inscribed angle. So you take this arc divided by 2, that's going to give you 47. So that means this angle inside this, or this inscribed angle right here, is only 47 degrees. Okay, so that 47 degree angle represents a 94 degree arc on the edge of the circle. Okay, so again, inscribed angles, the arc is going to be twice as much as the angle. Okay, in the next category we have circumscribed angles. Okay, that's when the angle is actually on the outside of the circle like this. Okay, and it intersects at 2 points. It has 2 tangent lines, you could say, right? 2 points of tangency. Okay, and it intercepts the arc outside like this. Okay, and if that's the case, the arc and the angle are going to add up to 180. Okay, in class we did a proof that kind of shows why that is the case. I won't take the time to go through it right now, but if you look, this arc right here that's intercepted by the 2 points of tangency, these 2 points, and this angle right here, add up to 180. So 482 plus 138 is going to give you 180. Okay, and that's the case for any circumscribed angle, an angle on the outside of the circle. You add up the 2 points, or add up the 2 angles, you're going to get 180. Okay, let's do a quick example problem. Okay, so let's say you have a angle right here, and this is equal to 56 degrees, and you want to know how much of this arc it intercepts, or how much of the arc it represents. Okay, you're just going to take this angle and minus it from 180, because you know that this angle plus this angle has to equal 180. So you also know that 180 minus that angle is going to give you the arc, which in this case is 124 degrees. Okay, so that arc represents 124 degrees of the circle. Okay, so this angle, that arc add up to 180. Okay, awesome. So just remember that the arc and the angle add up to 180 for a circumscribed angle. So the last case we're going to look at is what we call interior angles, and that's when we have a point or an angle on the inside of the circle, and it's just kind of anywhere random. It doesn't have to be at the center. And if that's the case, we're actually going to draw 2 different arcs to help us out. We're going to draw the arc on this side of the angle, and then we're going to mirror the angle as well and get the arc on the outside, on this side. Okay, and if that's the case, the angle on the inside, okay, the 75 degrees in this case, is the average of the 2 arcs. Okay, so I have an interior angle, I get this arc, I get that arc. The average of those 2 arcs is going to give me this inside angle, or this interior angle. Because in this example, if you look, you have 70 degrees and 80 degrees, right? So 70 plus 80 over 2 is my average. If you do 70 plus 80 divided by 2, that gives you 75, which makes sense. That's our interior angle. So it's the average of that arc and that arc. Okay? Let's look at another example to make sure we got this. All right, let's say we're looking at this circle. It has a interior angle that's not at the center. It's not a central angle. And we know that this arc that it makes on this side is equal to 86 degrees. And the arc that it makes on this side is equal to 74 degrees. Okay? And we want to find how much this angle is on this side. Okay? So this angle right here is just going to be the average of this arc and that arc. Okay? So we get 86 plus 74 over 2. That gives us our average. And if you add that up, you get 160 over 2, which is going to give you 80 degrees. Okay? Which means that this angle right here is 80 degrees, and also this angle right here is 80 degrees. Okay? Awesome. So just remember that you're taking the average of the 2 arcs to find the angle. Okay? And if you had the angle and you were trying to find the 2 arcs, you could also use that average as well. Okay? You just kind of have to work backwards, but you could use the same formula. All right, so those are the 4 angles we're going to focus on for this class: the central angle, the inscribed angle, the circumscribed angle, and the interior angle. And just a reminder of the 4 different ways you will treat those angles. Okay? So hopefully that makes sense. Let me know if you have any questions, and thank you for watching.